everyone, looking at class number 36. We're going to get a little bit more into horizontal projectile questions. So, read the scenario there. We have two cannonballs. One is dropped and the other one is fired. They're both from the same height, 20 meters. The one that's fired is fired horizontally at 30 meters per second. So which cannonball hits the ground first? Same time. Okay. Why? Well, they're the same height to start. And the fact that one is fired horizontally doesn't do anything. So we know that horizontal motion does not affect time of flight. Sorry, it's a little bit crammed in there. So how does the time it takes cannonball A to hit the ground compared to the time it takes for cannonball B to hit the ground? Same time. A little bit redundant, but just want to emphasize that they are the same amount of time. So if one of them takes 2 seconds, the other takes 2 seconds. So how long does it take cannonball B to hit the ground? Well, let's start with cannonball B. So we know the initial velocity, because it's dropped, is going to be, we'll call it V initial Y. We'll see Y a little bit later. So the initial velocity in the Y direction is 0 meters per second. The distance it is falling in the Y direction is 20 meters. And the acceleration in the Y direction is going to be 9.8 meters per second squared. All right, and how long does it take for time, t? All right, so we have our equation, d equals VIT plus 1/2 AT squared. So d is going to be 20. V initial is 0. T doesn't matter because it's 0 times t, 1/2, 9.8 t squared. All right, so we get something like, let's see, 20 equals 4.9 t squared. T should come out to be about 2.02 seconds. Make sure you can get that. But in class, it didn't seem like anyone had any questions on that one, 2.02 seconds. Therefore, I must say cannonball A the same amount of time, right? 2.02 seconds. Okay, so finding the time of flight of cannonball A is identical to finding the time of flight of cannonball B. What did we say the horizontal velocity of cannonball A was? We said it was 30 meters per second. Why doesn't it change in the air? So why is it 30 meters per second the whole time it's in the air? Well, hint, is there a force in the x direction? No, because there is no F net x. Therefore, AX equals 0. So the velocity is constant. So using our time, okay, so time is 2.02 seconds. And using our velocity in the x direction now, because it's not 0 now, it's 30 in the x direction. Find our distance in the x direction. It's not 20, it's going to be our distance in the x direction. Is going to be our unknown. And we know the acceleration in the x direction is going to be 0. So 2 ways to do this one. You could use this equation here, d equals VIT plus 1/2 AT squared. Now, when you go about doing that, d equals 30. The initial velocity is just the velocity, right? Because it's not changing at all. 2.02 plus 1/2. The acceleration in this case is going to be 0. And t is going to be 2.02 squared. That goes away. We have d equals 60.6 meters. The other way to do this one, or you could use this equation, v equals d over t. So v equals d over t is going to be 30 equals d over 2.02. And d also comes out to be 60.6 meters. Okay, so one little key about this equation here, v equals d over t. This is the only equation you can use in the x direction. Only used in x direction. Okay, you will never use this equation in the y direction. You will use no other equation in the x direction. Hey there. So looking at number 2 here, we have our goal is to measure the velocity of a ball rolling off a table. So we did this in class, and depending on which class you were in, we may have had different heights of the table, okay, and it may have rolled off different distances from the table. So we have our horizontal velocity or horizontal distance from the edge of the table was 0.35 for this class, or 35 centimeters, and the height of the table in this case was 83 centimeters or 0.83 meters. All right. So how long does it take the ball to hit the floor? This is just like what we did before, okay? We can say that the initial velocity in the y direction is 0, okay, because it's different than the velocity in the x direction. All of the velocities that rolls off the table is directed in the x direction at that instant. The acceleration in the y direction is 9.8 meters per second squared. The distance in the y direction is 0.83 meters, and the time is our unknown. So we're actually use the same equation as before. D equals VIT plus 1/2 AT squared. D is going to be 0.83. V initial is going to be 0 times T, so that whole term goes away, plus 1/2, 9.8 T squared. And I don't even know what this came out to be. Let me do the math real quick. So we're going to end up having 0.83 divided by 4.9. And we still have to take the square root of that. So the square root of 0.1. I believe the time came out to be 0.41 seconds. All right. So now we're going to use that with our horizontal velocity, or to find our horizontal velocity. So Vx is our unknown. Dx, I think we said, was 0.35 meters, and t is going to be 0.41 seconds. All right. So we can only use one equation in this direction. It's V equals d over t. V equals 0.35 meters over 0.41 seconds. And we get 0.35 divided by 0.41. We get about 0.85 meters per second. All right. So you could have also used in this direction d equals VIT plus 1/2 AT squared, where A would have been equal to 0. So it's just been d equals VT, very similar equation. All right, and these are some extra practice problems that you submitted. Right, we actually go over these next class in more detail. All right, so have a great day. Class 37 is definitely a good one to know for your quiz number 9.